The hurricane was still 4 days out, still floating offshore like a threat that might change its mind, when this company's operations system started moving inventory like it already knew what was coming. And that's the weird part, right? In most businesses, a storm on the horizon means, we'll wait for the forecast to tighten up, and then you get the usual scramble. Emergency shipments. Overtime. Some stores wiped out, others sitting on the wrong stock. A whole lot of chaos, held together with heroic effort. But this time, for days ahead of impact, the AI-driven operations platform had basically done the mental math no human team could do fast enough. It mapped likely storm paths, lined those up against inventory across a network of 40 warehouses, modeled what people would suddenly want to buy, and then started making changes. It diverted shipments away from routes that would probably become inaccessible. It staged water, batteries, and generators where demand would spike. It shifted inventory out of vulnerable locations into safer ones. It even nudged production schedules so replenishment would be ready for the post-storm wave. When the storm finally hit, shelves were stocked where customers actually needed supplies. Competitors were still reacting in real time. This company had already adapted. And the operations leader summed it up in a sentence that kind of sticks with you: we used to respond to the world. Now we get in front of it. That's the operational shift AI makes possible. Operations has always been the job of managing complexity: people, materials, machines, processes, routes, constraints, deadlines. AI isn't here to replace operational leadership. It's here to stretch it. It gives teams the ability to see more, coordinate more, and adjust faster than humans can on their own, especially when the system is too big to hold in one brain, or even one room. This is the second episode in our domain series, and today we're getting concrete about what intelligent operations actually looks like, from supply chain and logistics to process improvement and real operational decision-making. I'm Nakel Nakima, and this is the Intelligence Edge. Alright, joining me today is a 4-guest panel, people who sit right at the intersection of AI and operational excellence. Dr. Lian Zhou is an APAC AI transformation expert who's helped drive operations transformations across Asia-Pacific, where supply chains and manufacturing can be incredibly sophisticated. Dr. Zhou, welcome back.
Thanks, Nakel. Operations is one of the clearest places where AI's ability to coordinate at scale becomes visible, because the real world doesn't wait.
Maria Alvarez is a data governance leader with deep experience in the messy, real-time world of operational data, the stuff AI needs if it's going to do anything meaningful in a warehouse, a factory, or a fleet. Maria, great to have you.
Thanks, Nakel. Operational data can be a headache, but it's also some of the most valuable data an organization has, because it's tied to action.
Jonas Richter is a data ethics and compliance specialist focused on the human side of operational AI, safety, workforce impact, the ethics of optimization. Jonas, welcome.
Glad to be here. And yes, operations is where the ethics get physical and immediate because workers feel the system day to day.
And Kwame Mensah is an intelligence systems architect who builds the kinds of platforms that do real-time coordination, where AI has to meet forklifts, trucks, assembly lines, and actual constraints. Kwame, welcome.
Thanks, Nakel. In operations, AI stops being abstract. If it's wrong, you see it right away, in missed deliveries, downtime, or safety issues.
Let's start wide and then narrow down. When we say AI is transforming operations, what do we really mean? Dr. Zhou, if you had to map this transformation cleanly, how would you frame it?
I frame it through 3 capabilities, and they line up with the core problems operations has always faced. First is visibility. Operations leaders have historically struggled to get a single, real-time view of what's happening, where inventory sits, how shipments are moving, how machines are performing, where bottlenecks are forming. AI, paired with integration, can fuse those signals into a live operational picture. Second is prediction. Once you can see what's happening, the next advantage is seeing what's likely to happen: demand swings, disruptions, equipment failures, congestion. That storm example is exactly that. Not just predicting weather, but predicting the operational effect of the weather. Third is optimization. Operations is basically constrained optimization all day long. Limited trucks, finite capacity, labor schedules, service levels, costs, lead times. AI can optimize across more variables and refresh those plans continuously as reality changes. So visibility, prediction, optimization. Together, they move operations from reactive complexity management to proactive orchestration. You don't just survive the chaos. You coordinate ahead of it.
I like that, proactive orchestration. Kwame, from the technical side, what makes operational AI different from, say, AI in marketing or finance?
A few things make it distinctive. First, operations is real-time and physical. Stuff is moving. Machines are running. People are working. So the AI has to connect to sensors, equipment, and execution systems, and it has to keep up with the speed of the process. Second is sheer complexity. A supply chain can involve thousands of SKUs, hundreds of nodes, multiple constraints, and a ridiculous number of possible combinations. Humans simplify because we have to. AI can handle richer models and compute better solutions, if you give it the right data and constraints. Third, operations is disruption heavy. Weather, breakdowns, supplier delays, demand spikes, something is always off plan. That means operational AI can't be brittle. If it collapses the moment something novel happens, it becomes a liability. And finally, the consequences are immediate. If the system recommends the wrong routing decision, shipping ends up in the wrong place. If it schedules production poorly, customers feel it fast. That feedback loop is quick and very tangible.
So there's no hiding in slide decks. Maria, all of this depends on data. Why is operational data its own kind of problem?
Because it has a perfect storm of difficult properties. First, it's distributed across systems. You've got ERP, warehouse management, transportation, manufacturing execution, supplier portals, plus IoT sensors and logs. The data you need is scattered. Second, it's real-time. It's not a monthly report. It's a stream. Governing a stream is harder because quality issues propagate instantly. Third, it's heterogeneous. You're mixing structured transactions with sensor readings, GPS coordinates, images, event logs. Each of those has different standards, different failure modes. Fourth, it's high volume. Operations generates data constantly. And fifth, it's consequential. If a customer record is wrong, that's bad. If an inventory position is wrong, you can ship the wrong product, create stockouts, or idle a line. The errors turn into physical outcomes.
Jonas, when AI moves into operations, it also moves into people's workdays. What's uniquely human, or uniquely risky, about operations in particular?
Operations is where AI often touches the largest frontline workforce, and it does so in a way that can change daily life quickly. There's the workforce impact itself. Roles can disappear, but more often they mutate. People go from planning to monitoring systems, from diagnosing to following recommendations. Then there's surveillance. Operational systems can track productivity, movement, time on task. Some of that is legitimate, but it can easily become oppressive monitoring if you're measuring every second and treating humans like replaceable machine parts. Safety is a big one. Operations is hazardous by nature. Vehicles, machinery, heavy loads. If AI optimizes for speed or throughput in a way that erodes safety margins, that's not a minor bug. That's a moral failure and a legal risk. And work intensification is real. Optimization can remove slack, can push pace. You can end up with an operation that looks efficient on paper but is unsustainable and inhumane. So the question becomes, Are we using AI to make work better, safer, more predictable? Or are we using it to squeeze people until they break?
That's the tension right there. Okay, let's get specific. Segment 2, where does AI actually add value across operations? Dr. Zhou, give us the map.
I'll walk through it by operational area. First, demand forecasting and planning. AI can incorporate more signals than traditional forecasting: promotions, weather, events, local patterns, even external indicators. Better forecasts ripple through everything else. Second, supply chain optimization, sourcing, network planning, inventory positioning, distribution. When disruption hits, AI can recompute plans faster and across a wider network than humans can. Third, inventory management, balancing availability and service levels against carrying costs. AI can reduce both stockouts and excess by optimizing placement and replenishment. Fourth, manufacturing and production, scheduling, yield optimization, quality control, predictive maintenance. Fifth, logistics and transportation, routing, load building, fleet operations, delivery scheduling. Sixth, predictive maintenance and quality, anticipating failures and defects early. And seventh, workforce management, scheduling and task allocation, which is effective but, as Jonas said, ethically sensitive. One point I want to emphasize: the biggest gains come from integration, because these areas are connected. Optimizing one silo can make another worse. The real advantage is optimizing the network, not just a node.
Kwame, in practice, what's mature and dependable today, and what's still frontier?
The most mature, with clear ROI, are demand forecasting and predictive maintenance. Those have a long track record, and you can measure value: less downtime, better service, less waste. In the middle, maturing, you've got supply chain and inventory optimization at scale. The math works, but it demands serious data integration and good modeling of constraints. Same story for logistics: basic route optimization is proven, but the more complex you get, multi-leg, multi-constraint, real-time disruptions, the more careful you have to be. Emerging is what I'd call integrated operational intelligence: one brain across supply chain, production, logistics, and sometimes workforce. That's what the storm example points to. Powerful, but not easy. And then there's autonomous operations, fully automated facilities or logistics flows. It exists in limited contexts, but broad autonomy is still the frontier.
Maria, connect the dots for us. How does governance actually enable these use cases? People hear governance and think policy docs. What's the operational reality?
In operations, governance is what keeps the system from making confident mistakes at scale. Different applications need different foundations. For forecasting, you need governed demand signals, sales, promotions, external data, so the model isn't learning from noise. For supply chain optimization, you need accurate network data, suppliers and constraints, lead times, inventory positions, transport capacity, costs. If any of that is wrong, the optimal plan is wrong. For production and predictive maintenance, you need governed sensor streams and equipment histories. For logistics, you need reliable tracking, route constraints, service windows. The recurring theme is integration. If supply chain data is isolated from production data, you can't optimize the whole. The storm response story worked because inventory, logistics, demand, and production were connected. Fragmented data leads to fragmented intelligence.
Jonas, where do you see the ethical danger zones when companies apply AI across these areas?
The biggest danger zone is workforce optimization. Scheduling and tasking that creates unpredictable lives, relentless pace, and no room for recovery. Efficiency that destabilizes people isn't sustainable. Second is monitoring. There's a difference between ensuring safety and tracking every movement, every break, every second. When people feel watched all the time, trust erodes and dignity is harmed. Third is safety trade-offs. Safety needs to be a hard constraint. If the system discovers, that shaving a few seconds improves throughput, humans must still say, "No, that's not allowed." Fourth is algorithmic management, AI assigning tasks, rating performance, influencing pay or discipline without transparency or recourse. Being managed by an opaque system can feel dehumanizing. And lastly, displacement. If automation removes roles, there's an ethical responsibility to support people through transition. Retraining, redeployment, fair severance, honest communication.
Let's go deeper into supply chain, because that's where the transformation feels most dramatic right now. Dr. Zhou, what's fundamentally changing?
Supply chain is shifting from something linear and periodic to something networked and continuous. The old mental model was a chain, supplier to factory to distributor to retailer. Planning happened in cycles, and disruption response was basically firefighting. Visibility was partial, because everyone saw their own piece. AI enables a different model, the supply chain as a dynamic network. Visibility can extend across tiers. Planning becomes continuous, always adjusting. And response becomes anticipatory, because you're predicting disruptions and adapting before they hit. That changes the resilience versus efficiency trade-off. Historically, resilience often meant expensive buffers, extra inventory, redundancy, slack. AI-enabled networks can be efficient in normal times and resilient in abnormal times because they adapt rather than relying only on static buffers.
Kwame, when people hear AI supply chain, it can sound like magic. What's actually in the box?
It's a bundle of capabilities working together. First, end-to-end visibility, integrating data across suppliers, inventory, production, logistics, and demand so you can see what's happening now. Second, demand sensing, using broader signals than just historical sales, weather, events, channel data, local patterns, to detect shifts early. Third, disruption prediction, monitoring risk signals, weather, port congestion, supplier performance, geopolitical indicators, and estimating impact on the network. Fourth, dynamic optimization, recalculating sourcing, inventory placement, routing, and production plans as conditions change. And fifth, scenario simulation, asking, what if, constantly so when something happens, you're not starting from scratch. One design principle matters here, integration. Visibility alone becomes dashboards. Prediction alone becomes alerts. The value shows up when the system can sense, predict, and then actually reconfigure the plan.
Maria, supply chain crosses company boundaries. How does governance change when partners are involved?
It becomes governance of data, partners, and decisions. On data, you need agreements on sharing, standards, and quality, because the visibility you want doesn't stop at your ERP. It includes suppliers, logistics providers, sometimes retailers. On partners, AI-driven optimization can shift orders, reshape schedules, reallocate volume. That affects relationships and power dynamics. Governance needs to define what's fair and how changes are communicated. On decisions, you need clarity on what can be automated, what requires review, and how recommendations are validated. High-stakes moves, like major sourcing shifts, should have human oversight. And then resilience. You also govern what happens when the AI is wrong or the world is new. You need fallbacks, manual capabilities, and a plan for AI failure itself.
Jonas, what risks show up specifically when supply chains get AI optimized?
One is fragility from over-optimization. If you squeeze out every bit of slack, you may lose the buffer that helps you survive shocks. If the model assumes normal conditions, abnormal conditions can break it quickly. Another is correlated decisions. If many firms use similar models and optimize similarly, they can all converge on the same best suppliers, the same inventory reductions, the same responses to signals. That creates systemic risk. Everyone becomes vulnerable to the same assumptions. Then there's opacity and accountability. When decisions harm a partner or a downstream community, who is responsible? The model? The vendor? The COO? Accountability can't disappear into complexity. And power dynamics matter. Large companies can use AI to push variability and risk onto smaller partners, demanding flexibility and absorbing the gains. AI can magnify an imbalance if you're not careful. The lesson is, appreciate the limits of prediction. The storm might be predictable. The next disruption might be a true surprise.
Let's pivot to predictive operations and maintenance, one of the most practical places AI has proven itself. Kwame, walk us through predictive maintenance like you would to an operations leader deciding whether to invest.
Sure. Traditionally you had two approaches. Reactive maintenance, you fix equipment after it breaks, which creates unplanned downtime and sometimes catastrophic failures. Or scheduled maintenance, you replace parts on a calendar, which can mean replacing too early or missing failures between service intervals. Predictive maintenance sits in between, using data to intervene at the right time. Step 1 is collecting sensor data, vibration, temperature, pressure, acoustics, electrical signals, whatever indicates equipment health. Step 2 is learning normal versus abnormal patterns. The model learns what healthy looks like and what pre-failure looks like. Step 3 is anomaly detection, spotting subtle deviations early. Step 4 is predicting failure windows, not just, something's wrong, but, this component is likely to fail soon. And Step 5 is optimizing maintenance scheduling so you repair when it minimizes downtime and cost. That's why it's such a strong entry point. The ROI is measurable, less downtime, fewer emergencies, longer asset life.
Dr. Zhou, zoom out for us. Predictive maintenance is one use case. What's the bigger picture of predictive operations?
Predictive maintenance is a gateway into a broader idea, operations that prevent problems instead of constantly fighting them. Predictive quality means detecting conditions that lead to defects and intervening early. Predictive demand means seeing demand shifts before they fully show up in orders and adjusting capacity and inventory. Predictive disruption means anticipating supplier issues, logistics constraints, or weather events and adapting before service is impacted. Predictive capacity means identifying future bottlenecks and planning expansions or shifts in advance. And predictive safety is especially important, anticipating risk conditions that lead to accidents and preventing them. The unifying theme is simple, operations that can see ahead. You move from firefighting to prevention, from constant scrambling to steady orchestration.
Maria, what does the data foundation look like when an organization wants to do predictive operations well?
It's heavier than many teams expect. You need sensor infrastructure, because many predictions require data from equipment, processes, and environments. That means high-volume streams and reliability. If sensors fail or data drops, your prediction breaks. You also need history. Models learn from past failures, past conditions, past outcomes. If an organization hasn't been collecting that history in a usable way, it's hard to build predictive capability quickly. Then you need outcome tracking so you can validate predictions. Did the failure actually happen? Was the defect prevented? This feedback loop, connecting predictions to outcomes, is vital. And finally, integration. Predictions are stronger when you can combine internal operations data with external signals. None of this works well if data is fragmented.
Jonas, when operations becomes predictive, what changes for frontline teams?
Can get better in meaningful ways. Predicting failures and hazards can improve safety and reduce accidents. And it can reduce the constant stress of emergency response. Planned work is less chaotic than reactive work. But there are risks. Desk killing is one. If AI is doing diagnosis, workers can lose the craft of troubleshooting. They can become parts replacers rather than skilled maintainers. Another is surveillance creep. Systems built to monitor machines can end up monitoring people. And predictive optimization can intensify pace if the system squeezes out downtime that used to be a breathing space. So again, it's design and deployment. Predictive operations can elevate work, or it can narrow autonomy and increase pressure.
Segment 5 is about the destination. If we fast forward, what does an intelligent operations function actually look like? Dr. Zhou, paint the picture.
Intelligent operations has a few defining characteristics. It's anticipatory, acting ahead of demand shifts and disruptions rather than responding late. It's adaptive, plans are living, not static, so the system flexes with reality. It's orchestrated, supply chain, production, logistics, and workforce aren't optimized as separate islands. They work as a coordinated whole. And it's continuously optimized. AI recomputes configurations as conditions change, across complexity humans can't manually manage. But the most important trait is human-centeredness. If the operation becomes smart, but treats people as disposable variables, it's not truly intelligent. The goal is an operation that's both effective and humane.
Kwame, what's the technical stack that makes that vision real?
You need an integrated foundation. First, a unified operational data layer, bringing together supply chain, production, logistics, workforce data, and sensor streams. Second, a real-time visibility layer so everyone, including the models, sees the live state of the system. Third, a predictive intelligence layer, models for demand, disruptions, failures, and risk. Fourth, an optimization layer that can compute plans under constraints and update as conditions change. Then a human interface layer, the practical tools that connect intelligence to planners, supervisors, and operators, so AI is actionable without removing human judgment. And finally, physical integration, connections to sensors, machines, warehouse systems, fleet systems. Because in operations, the digital model has to stay aligned with the physical world. Integration is the hard part. The value appears when these layers behave like one coherent system, not a bunch of disconnected tools.
Maria, what kind of governance keeps intelligent operations reliable and safe over time?
In operations, governance is less about bureaucracy and more about preventing failure. You need reliability governance because failures have immediate consequences. Systems should be tested, monitored, and designed to degrade gracefully. You need resilience governance because disruption is normal. You need clear intervention paths when the AI hits something it wasn't trained for. Data quality governance is constant, real-time quality checks, anomaly handling, lineage, because bad data becomes bad movement, bad production, bad service. Safety governance is critical. Safety must be locked in as a non-negotiable constraint. And worker welfare governance matters too. Guardrails so optimization doesn't become harmful intensity. Finally, dependency governance. If you come to rely on AI for core operations, you need a plan for when it fails, fallback processes and maintain manual capability.
Jonas, close out this vision with the human role. If AI handles more coordination, what do humans do in intelligent operations?
The human role shifts toward what machines don't do well. First, judgment under novelty. AI is trained on patterns. When reality breaks patterns, like a true, unprecedented disruption, humans have to interpret, decide, improvise. Second, oversight and intervention. People must remain competent enough to step in. If you automate away the skill, you lose the ability to correct the system when it matters most. Third, ethical balancing. Deciding what trade-offs are acceptable, how to prioritize safety, fairness, dignity, those aren't purely mathematical choices. Fourth, leadership. Operations is still a people business. Coaching, communicating, building trust, developing teams. And lastly, accountability. Someone must be responsible for outcomes and for how workers are treated. That responsibility can't be delegated to a model.
All right, let's hit our tactical edge segment, practical actions leaders can take this week. Dr. Zhou, what's your move?
Ask a simple diagnostic question. Are we reacting, or are we anticipating? Pick your biggest operational pain points, disruptions, demand volatility, equipment downtime, and map where you're still in pure reaction mode. Those are your best candidates for predictive operations.
Maria, your tactical step.
Assess operational data integration honestly. Can you see the operation end-to-end in near real time, or do you only see disconnected fragments? If supply chain, production, and logistics are siloed, intelligent operations will stay out of reach. Integration is the foundation.
Jonas, what should leaders check this week?
For any operational AI touching workers, run a human impact review. Ask, are we optimizing people like variables or supporting them like humans? Look specifically for surveillance overreach, schedule instability, unsafe pressure, and dignity issues. If efficiency is paid for with harm, it will become a sustainability and retention problem besides being ethically wrong.
Kwame, bring us home.
Pick a critical asset or process and check predictive readiness. Do you have the sensors? Do you have the historical failure data? Do you have outcome tracking so you can validate predictions? If you're still purely reactive or purely calendar-based, predictive maintenance can be a fast win, but only if the data foundation exists or you have a plan to build it.
Let me stitch together what we covered today. AI reshapes operations through three big capabilities: visibility, prediction, and optimization. When those work together, operations stops being a constant reaction cycle and becomes proactive orchestration, the ability to see ahead and act ahead, like that warehouse network that effectively prepared for a hurricane before most people had even decided to worry. Operational AI has its own personality, it's real-time, it's tied to the physical world, it's massively complex, it's disruption-prone, and the consequences show up immediately. That makes the data challenge intense too: distributed, streaming, diverse formats, huge volumes, and very little room for error. We mapped where AI creates value: forecasting, supply chain, inventory, production, logistics, predictive maintenance, workforce management, and we talked about maturity. Some of this is proven, some is maturing, and integrated intelligence plus autonomy is still frontier for many organizations. We also zoomed in on supply chain, where the shift is from linear and reactive to networked and anticipatory, potentially delivering efficiency and resilience at the same time. But we warned about over-optimization, systemic fragility, opacity, and power dynamics. And we talked about predictive operations as a bigger movement, not just predicting maintenance failures, but predicting quality issues, disruptions, safety risks, and capacity constraints, pushing operations away from firefighting and toward prevention. The destination is intelligent operations that is anticipatory, adaptive, orchestrated, continuously optimized, and crucially, human-centered. Because operations isn't just flows and constraints. It's people. And the intelligent COO has a dual mandate: make operations more effective and make it more humane. Dr. Lien Zhou, Maria Alvarez, Jonas Richter, and Kwame Mensah, thank you for an essential conversation.
Thank you, Nakel.
Really enjoyed this. Thanks.
Vital topic. Appreciate the space to talk about the workforce reality.
Always a pleasure. Thanks for having us.
Next week on the Intelligence Edge, we continue our domain series with AI for Strategy, the Intelligent CSO. We'll dig into how AI changes strategic leadership, competitive intelligence, scenario planning, and the way big strategic decisions get made. Until then, I'm Nakel Nakima. Make better decisions.